All right, let's continue. In the last episode, we added our Blinky, which is still happily blinking along. And we wanted to add Embassy so we can use async runtime. First of all, I took a lot of inspiration from a blog post of a guy called Benedict from Germany. It helped a lot. I will link it in the notes, but it's two really nice articles, and I suppose I would have figured it out without this article, but it would have taken me a whole lot more time. I think so. Yeah, thanks a lot, and a shout out to him. He would like to have some yeah, so some donations. So if you can sponsor him, uh, I think I'm sponsoring him, and if not, no, I guess I'm not. I will sponsor him because he's just good and he's a student. He can use the money, so big shout out. Anyway, moving on. So adding Embassy. It is not as simple as just adding a dependency. That would be really nice if that was the case, but that's not quite how it is. And if you think about it, it kind of makes sense because it really needs to integrate with the hardware, right? It needs to respond it needs timers. If you say delay for, I don't know, 100 milliseconds, what it basically does, it freezes the current state, sort of, and sets an alarm for that it needs to be reactivated in 100 milliseconds. So you need to have the integration. You need to have integration with like network stacks. If a packet arrives, if a pin, an input pin value changes up or down. So it is not that simple. So let's get started. So first of all, what we need is to add some things to the hardware abstraction layer. So actually, the hardware abstraction layer, which is specifically the one for the C3, needs some features, and those are it needs to have the I have written it down somewhere. Yeah, so this has a feature called Embassy. So you can need to make it into this. So you can tell how closely intertwined those things are. They are aware of each other. There is the Embassy. There is Async. And there is one more, and that's the Embassy time. Let's see if we can look that up. It's something with time. Docs RS. Let's see if we can find this one. And then we see what features are there. This one. There's the timing group 0, I think, and that's important. So let's add this one here and see if this still seems to be happy. So that's the updating the hardware abstraction layer. We can use the cargo add for some of the other things. So we do cargo add Embassy time. I don't think we need features. I think that's okay. Embassy is time 1.3. It needs to be We need a net. No, we don't really need that right now. We do need an embassy executor. Let's see how this goes. I do need, I think, maybe the features, nightly, and the integrated timers. It could be that this one in particular will need the Git integration, so not a released package. We have done this, so let's get. Oh yeah, and there's another thing we need. We need to, in order to appease the borrow checker, it helps to static cell. It's called like this. Yeah, so that makes life a little bit easier because yeah, as we all know, Rust really is strict on the lifetime, but for this, those top level things, they have the same lifetime as the whole run, right? So there is not really any point in making it complicated. So let's create an executor for that. So first of all, we need to get started, and for that we need to create an executor static. So that's a static executor. It's yeah, it's whenever you use a static, you should use capitals. You don't have to, but it's kind of the accepted code style. Static cell, and we need that of an executor. That one, yes. And then we say static cell new. And maybe we need to import some things still. Yeah, this is not good. This is not the executor I had in mind. I think the executor should not. You shouldn't use the Git version. Let's see if we can just make this thing happen. This is of course not an ESP32, that's an embassy. Let's see what this does. So yeah, this is the price of being a little bit avant-garde in technology, that we need to deal with these things from time to time. What did I do wrong? Quick check of the URLs. I just had the wrong one. Alright, so the dependencies seem to be alright. And let's see if we can get the executor I had in mind. No, we don't. me see here, there is a specific revision. I did not know that was that tight, but let's figure that one out. It says it seems pretty happy. Let's see. Yeah, so before we only had the raw executor, and I wanted this one. So now that should work. Okay. Moving on from here. So that's good to remember that this is pretty important to get right. So before we can make an actual executor, let's leave the Wi-Fi code as it is for now. Now let's do it before here. We'll need to create a timer group, and so a timer group will be responsible for yeah, the scheduler will need a timer group to do all the precise timings that it depends on. Timer group, new. What needs to be in there? A timer group. That makes no sense. I think it's in peripherals. Yeah, that one. I think clocks we already have. Yes. But borrowed. And finally, peripheral clock control. I think that's in system. It wants a mutable link to that. Let's give it that. And then we need to make system here mutable, not a problem. So now it worked. There is something weird here, I don't know why, but the whole like autocomplete doesn't work around this one. So generally in this space, don't rely too much on the Rust analyzer. If it kind of claims something doesn't exist, might not be true. So sometimes it helps to just keep on typing where if you really convince something is there, and then you'll see. So we have a timer group, then we can continue and to actually create an executor. So let's above we create executor static, right? So executor, we're gonna initialize it, and we're gonna initialize it by creating an executor new, and then we have that, and then we need to actually initialize the. So now the static we created now has actually something in it. So let's change the order. That should kind of makes more sense. And now we're gonna need to initialize the embassy itself. Now, so it's in embassy. There's an init, and that needs something. Okay. It needs a clock and a timer group. So clocks, I think, and timer group. Yeah, we need to take the timer from there. Yeah. Okay, so now we have most of our initialization done. We're getting there, and the next part is where let's move this one up as well. We've already done that. No, that makes no sense. Here. Now we can actually start the executor. No, oh, I didn't assign it to anything. So executor. So this, no, it's the wrong one. So now we have an actual type in executor, and then we can call into that dot run, and there is we pass a lambda in here, which takes a spawner parameter, and with that we can initialize tasks. So that looks something like this: spawner, and then do things. Those things are specially annotated functions. So it takes something like, you need to make a function, let's say blink green. That will do something. We need to add some things. We need to make sure they're async, because we are going to schedule it as async, and it needs a special annotation, and that's an embassy executor task. Yeah, it says I need to the infiltrate. Need to add this. Okay. And now we can schedule this task. So we use our spawner. We spawn, and we need to pass in that method blink green, I think. And it returns results, so let's unwrap it. Okay, so now we have a blink green. Let's pass the pin into it so it can actually reach it. Let's check what the type is. GPIO output. So it needs a pin, and it's a GPIO 4, I think, output push pull. Is this correct? Okay. And here we can do pin dot. No, we're not there yet. So we're scheduling this. Right now you see this gets a warning now because it's unreachable. This executor here will never terminate. It will just keep on running forever. So anything else we want to do, we need to make sure that we take care of that in our tasks. So this loop, we can just take it and dump it in here. So this is different, and also this is this delay we're doing here. Yeah, it's also defined here, but this is a kind of hot delay. It really blocks, and that's what we don't really want anymore. We want to basically indicate that it can just do something else until a certain amount of time has elapsed. So we use the timer for that, and we say after. We had like 500, so we do maybe, let's do a little bit less, so at least we can see the difference. Really take care to import the right things, and if things don't get accepted, check your imports, because sometimes you can easily import the wrong thing, and that happens a lot in Rust. There's a lot of classes and methods and functions that have the same name. So as millis, maybe 200 millis. No, I don't mean that. I mean from millis. And then we need to await it, because again with this needs to be mutable. So it's always important that you add await, because if you don't add await, it really doesn't do anything. And in this case, it is kind of a weird thing to do, right? Because we are calling a function here that obviously will never return. It will never be done. But it will await. So every time it gets in here, it kind of pauses the function again, gets out, and then the timer will reschedule it after that time. So it is a kind of comfortable way of playing with this. So let's see if this does what we expect. Let's go back into our Flash. It's a bit bigger now, but not much. It was, I think, 24 before, so now it's 27. And we see that the blinking has increased, so it definitely did change. So in itself, of course, like this is, if this is all we want to do, it doesn't really make sense to add all this complexity. But for example, this doesn't need to be mutable. If we want to blink the red one as well, let's do that. So we're gonna make a blink red. That's gonna take pin 3. It's a multicolor LED, so it will look a bit weird maybe. So we just copy paste all the things. Pin 3. Oh, what happened? Pin 3. Pin 3. And we just need to copy this one as well. Get this alignment right. Red, pin 3, and import it. And let's take a different frequency, like I don't know, something really different. So it will be totally async. Let's see what that does. Huh? Don't know what happened here. Weird hiccup. And now you get like a sort of psychedelic effect. So now there are two blinks. There is the red one and the green one that are blinking asynchronously, and sometimes it's yellow when they're both on, and sometimes they're both off. But this kind of thing would be really a lot harder without the async, right? Because then you need to think like, how is this exactly gonna flow? I guess you can calculate it and get it all right, but this is a whole lot easier. So this is all I wanted to show today. Let's next time let's add Wi-Fi. It's a lot more involved than with the standard. It takes quite a bit of boilerplate. So yeah, let's get through that, because it is in the end what makes it all interesting. All right, take care. See you soon. And yeah, I had some really nice feedback, so thank you very much for that. That really helps motivating. So if you can give me a like, or if you have ideas for episodes, I have a few in the pipeline, but I really would like to have some concrete plans, concrete ideas. So yeah, a like, a comment would be really nice, and see you around. Bye.